Welcome back to Azure AI Essentials. In this video, I'll show you how to build chatbots on Azure. Chatbots are useful in a variety of scenarios. Simple informational chatbots can be used to handle a large volume of frequently asked questions. Converting FAQ content into a conversational experience can help your employees and customers quickly get the information they need. In the case of the CDC, they built this type of chatbot to help people self-check symptoms for COVID-19. Next, we have transactional chatbots that are used to empower end users to self-serve. Take, for instance, a customer who wants to place an order and later get an updated order status. This requires the chatbot to retrieve and sometimes edit records in your existing IT systems. For example, UPS built a chatbot to enable customers to self-serve and get a status on their packages. Finally, dynamic and contextual bots are even more sophisticated. These chatbots are context-aware and can do things on your behalf that make you more productive, like make reservations, update your calendar or to-do list, make recommendations, and more. A great example is Universal Electronics, which built a voice-enabled virtual assistant to help customers control their smart homes. Next, I'll walk you through the tools you can use to build these types of chatbots on Azure. Let's start with a simple informational Q&A bot. This type of chatbot can help organizations scale to more easily answer frequently asked questions, while enabling specialist resources to handle more nuanced requests. In addition to the CDC, another example is Accenture, who built a chatbot to help answer common onboarding requests from new employees. Other common use cases include IT help desk password resets and customer service FAQs. The fastest way to build this type of chatbot is to use Q&A Maker, an Azure Cognitive Service which helps developers quickly convert information into a question-and-answer conversational experience. If you already have an FAQ document or product manual, all you need to do is upload the document or paste the page URL within the Q&A Maker portal. You can test the chatbot, edit the Q&A pairings, and add new ones within the Q&A Maker portal. You can also add alternative phrases, which are additional examples of how a user might ask the same question, which helps increase the accuracy of the answers returned. Inevitably, users will ask questions outside the scope of the chatbot. To help you address these questions, Q&A Maker offers thousands of small talk questions in 5 different personas to help match the personality of your bot. When configuring a bot in the Q&A Maker portal, you can select one of these personas to handle questions like, tell me a joke, or when's your birthday? These informational chatbots can be really helpful to answer inquiries from employees or customers. However, chatbots are capable of handling more complex scenarios, including allowing users to self-serve, to retrieve and edit information in a database. Chatbots can be created to handle sophisticated scenarios. For example, Progressive lets users generate an insurance quote just by chatting with their bot, Flo. In the next few minutes, we'll cover key steps to build more advanced chatbots, including transactional chatbots, as well as dynamic, context-aware chatbots. The Azure services we'll cover are Bot Framework, Azure Cognitive Services, and Azure Bot Service. And our example today is an internal HR vacation bot, which helps employees with tasks like checking how many vacation days they have left and booking vacation. For a no-code, out-of-the-box solution for business users to build a chatbot, we also offer Power Virtual Agents, a SaaS offering built on top of the Bot Framework. So let's dive in. The first step is to build the chatbot application using the Bot Framework, an open-source SDK and set of tools available on GitHub to help developers design, build, test, publish, and connect their bots to their end users. The Bot Framework SDK offers a code-first bot development experience available in C#, Node, Python, and Java, with bot templates and samples available in the Bot Framework GitHub repo, so you can build using your preferred tools and IDEs. In addition to the SDK, you can use the Bot Framework Composer, a visual tool for building chatbots, which we'll use in our example. It lets you accelerate the bot development process by allowing you to focus on the dialogue authoring rather than creating a bot from scratch. You'll start by creating a new project in Bot Framework Composer. On the left, you have a list of triggers, which are used to respond to external events, like a message being received from a user. Here, we start with a built-in greeting trigger, which is the bot's response to a user joining the conversation. A subsequent trigger might be a user question, and you can edit what your bot will say in response. You can create a new trigger and provide example phrases mapping to that user intent. Here, we're adding phrases indicating that a user wants to book a vacation, and behind the scenes, Composer is automatically creating a natural language processing model to understand user intent using Azure Cognitive Services. You can then build out the dialogue using the authoring canvas, giving the bot the ability to reply back or take action based on what the user says. For a conversation that feels natural, you can give your bot a choice of phrases to choose from for its response. You can also store a user's response as a variable and add that user input into the bot's response later in the dialogue. Here, the user gives a reason for wanting to book a vacation, and the bot can refer to that reason later in the conversation. Once you've built your bot application, you can improve your user experience by adding intelligence to your bot with Azure Cognitive Services capabilities across vision, speech, language, and decision. Language and speech capabilities are the most commonly added to bots. In fact, you can use these services directly from within the bot framework. For example, the speech service can be integrated into your bot via the direct line channel in Azure Bot Service. So you can enable voice interactions like transcribing speech to text, creating a custom keyword, and adding text-to-speech capabilities with support to create a custom voice for your bot. Additionally, the language understanding service, used to understand your user's intents, and Q&A Maker, which we discussed earlier, can be used directly within Bot Framework Composer. Let's see this in action. To enable this bot to answer FAQs, Composer can use the Q&A Maker service to create a knowledge base for you, and you can edit the question and answer pairs directly in Composer. Going back to the design page, you can see that there's a new Q&A trigger, which fires when an incoming user request matches an answer in the knowledge base. This bot is also using language understanding, so you'll need to create a cognitive services resource. When you're ready to test and publish your bot, you'll add the authoring key, which you can find in the Azure portal where you'll create your resource. When you do this, Composer will create and publish a LUIS model for you. Speaking of testing, now that you've built the bot application with Bot Framework and added AI models with Cognitive Services, you're ready to test your bot. If you use the SDK and code-first tools, you can run the app locally in Visual Studio or the IDE of choice. If you use the Composer, you can use the Bot Framework emulator. Simply click Test in Emulator and test your bot from there. You'll see your welcome message because your greeting trigger was fired when the conversation started, and you can begin testing your chatbot. Additionally, you can add context awareness by building skills to extend your bot further. We have a set of Bot Framework skills to get you started, including a calendar skill to schedule meetings, a to-do skill to manage task lists, a weather skill for information on local weather, a point of interest skill to incorporate maps information, and more. One thing to note is that each skill comes with a pre-trained language model for that specific scenario, but you can still further customize these models to understand intents and entities. Once you're done testing your bot, you can publish it to Azure using Azure Bot Service, which will host your bot and connect it to popular channels. You can surface your bot through several different channels, including Microsoft Teams, Slack, Facebook Messenger, Amazon Alexa, and more. To publish your bot to Azure Bot Service, you'll create a new publish profile and then deploy either to an Azure web app or an Azure function. Then you can navigate to the Azure portal and test to make sure that your deployed bot is working correctly. Now you can connect to the channel of your choice. Here we're publishing to Microsoft Teams, and the vacation bot is now ready to help employees book vacation and answer frequently asked questions. There are so many ways you can use bots to help provide useful and engaging experiences for your customers and employees. From providing an efficient way to get crucial information, to helping complete tasks, to enhancing productivity. We hope you found this video useful, and we look forward to seeing the conversational AI solutions you build on Azure.